In this video, you'll be introduced to the concept of arc length. Before we can talk arc length, we have to introduce you to a new unit of measure for angles. Here's how I want you to think about this. Just like we can measure the length of a line segment using different units of length, like inches, centimeters, feet, or miles, we can do the same thing for angles. The unit that you've been using up until now for angles is degrees, but we can also measure angles in something called radians. The radian measure is going to be equal to the ratio between the arc that the angle intercepts and the radius of the circle. So in other words, theta radians is equal to the comparison between s, which is the representation for arc length, and the radius. This formula you do need to memorize. I like putting this over 1 and cross multiplying so that when I cross multiply in the first direction I get s, and when I cross multiply in the other direction I get theta times r, because I call this formula the SOHR formula. Yes, it's a little corny. Yes, it's a little bit dorky, but it does help me remember the formula. And in the SOHR formula, S represents arc length. Theta is always the measurement of the angle in radians. That's really, really, really important. This formula does not work if the measure of the angle is given to you in degrees. And of course, R represents the radius. So let's jump in and let's see how this might look in some examples. In a circle whose radius is 20, a central angle intercepts an arc of 15 centimeters. Find the number of degrees in the central angle. So we know that R equals 20 centimeters. We know that S equals 15 centimeters. And we're trying to find theta, which would be, we're not quite sure how many radians. So I'm going to call that X. My formula is SOHR. I'm going to substitute in 15 in place of S. I'm going to plug in X in place of theta. I'm going to plug in 20 in place of R. So 15 over 20, my calculator tells me is X. So X, or theta, is equal to 3/4 of a radian. And again, that radian is just a different unit of measure for measuring an angle. In the second one, we're given that a central angle of pi over 4 radians intercepts an arc that's 3 inches long. Find the radius. So we're trying to find the radius. We know the arc length is 3 inches, and we know that theta is pi over 4 radians. And again, it's very important that that angle measure be given in radians because this formula only works when the angle measure is given in radians. So 3 is equal to pi over 4 times the radius. So I'm going to go ahead and multiply both sides by 4 over pi so that the pi's cancel and the 4's cancel. I've got to multiply this side by 4 over pi. So when I multiply the numerators, I get 12. When I multiply the denominators, I get pi. So I find that the radius is going to be equal to 12 divided by pi inches. If I were to be asked to find that to the nearest inch or to the nearest tenth of an inch, I could just plug it into my calculator and go from there. In number 3, we're told that the radius is 9 centimeters. We're told that theta, the central angle, is 5 radians. And we're asked to find the length of the arc. So we're looking for S. So again, my formula, I'm going to substitute in, I'm trying to find S. My angle is 5 radians, my radius is 9 centimeters. So S, or my arc length, would be 45 centimeters. So hopefully you can see that this really isn't a whole lot more sophisticated then just identifying what you've been given and substituting into the formula. So the arc length, S, is 6 centimeters in number 4. The central angle, or theta, is 1.5 radians. And we're trying to find the number of centimeters in the radius of the circle. So again, I've got my formula. I'm going to go ahead and substitute in 6 in place of S. I've got 1.5 times R. So I'm going to go ahead and I'm going to divide both sides now by the 1.5, making my radius 4 centimeters. All right, well, that's about all I have for you on arc length. As always, I want you to go ahead and put the key ideas in your own words and see what you can do with the questions on the next page.